Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR November 2019, paper 2, foundation tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1, work out 89 plus 14. So we've got some straightforward addition here. I just recommend that you use like a column method to add these together. So 9 plus 4, that's 13. So I write 3 down here, carry 1 into the next column, and then I've got 8, 1 and 1 adds up to 10. So the 0 goes there, the 1 goes there, and my answer is 103. Part B says 17 times 21. Now for your exam you're going to need a decent method for multiplying. Now if you can already multiply using column multiplication, that's fine, that's great. If you are struggling with it or you make mistakes regularly, you might want to have a look at this method instead. I call this one Napier's bones, other people call it different things. But what you do is you take your first number here and you write it along the columns of your grid, and then you take your next two numbers here and you write it down the sides on the rows, and then you have this kind of weird grid. It's got 4 cells, but each cell has been divided in 2 with a diagonal line. Okay, probably the hardest thing about Napier's bones is drawing the grid. Once you've drawn the grid, then you just multiply the number. So if I want to work out the numbers here, I'm going to be multiplying that number there at the top of the column and that number there at the end of the row. So what is 1 times 2? 1 times 2 is 2. So I'm going to write down, I've got 0 tens and 2 units for that answer there. Okay, now in the next cell across, this one here, that is in the 7 column and the 2 rows. So I'm going to multiply 7 by 2 here. Now 7 times 2 is 14. So I'm going to write the 1 from the 14 in there in the top box and the 4 from the 14 down here. In the next row, 1 times 1 is 1, so that's 0, 1. And 7 times 1 is 7, so that's 0, 7. Now the nice thing about Napier's bones is then you can then just add up along these diagonals. Okay, so you don't need to remember how to carry you don't have to remember how to add zeros in and things like that. You can just kind of add up along the diagonals. So in that first diagonal I've got a 7, in the next one I've got 4, 0 and 1, that adds up to 5. The third one is 1 and 2, adds up to 3, and then I've got 0 on the end here. So my answer then is this round here. It is 0357 or 357. So that's my answer, 357. Okay. Well, like I say, if you already know how to multiply, you can do it without mistakes. Just stick with your method. If you don't, then maybe this is one for you to try. Question 2. The table shows some temperatures in degrees Celsius. Monday was -5, Tuesday -1, Wednesday 5, Thursday 6, and Friday -3. It's all quite cold. Find the difference between the temperatures on Thursday and Friday. Now, difference in maths means subtract. So we're basically taking one away from the other. if I had 6 and I subtract -3, what's that then? Okay, well, first off, I'm going to deal with this double sign here. Taking away a negative, that's the same thing as adding, isn't it? That's the same thing as 6 plus 3, and 6 plus 3 is 9. So there's a difference of 9 between those two numbers. The other way of doing it, of course, you could have drawn a number line, -3, -2, -1, 0, all the way up to 6, and then counted the number of jumps between them. That would have given you the same answer. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so either of those approaches is good. Next one. On Saturday, the temperature was 7 degrees higher than on Friday. Find the temperature on Saturday. Okay, so if I want to go 7 jumps up from -3, so it's -3 on Friday, so I'm going to start in the same point, and I'm going to jump up 7 this time. 1, 2, 3, 4, 5, 6, 7. That takes me up to +4, doesn't it? So it's going to be 4 degrees on Saturday. Question 3. Complete each statement by writing the missing value in the box. Okay, so now the first one, I've got 2/5, and then that's the same thing as 4 blankety blanks. Okay, now if you look at what the difference is between there and there, to get from 2 to 4, I'm going to multiply by 2. So if I do the same thing on the bottom number, times it by 2, 5 times 2 is 10. So 2/5 is the same thing as 4 tenths. Okay. With this next one, I've started off with a mixed number, and presumably I want to write it as an improper fraction or top-heavy fraction. Now to do that, I'm going to take these two numbers at the bottom first, the 2 and the 3, and we're going to multiply those together. 2 times 3 is 6, and then we add this number on the top, which is 7. So that's the same thing as 7/3. Okay. Now the other way you can think about it is if you've got like 2 pizzas that are divided up into 3 pieces each, then 2 whole units then is got 1, 2, 3, 4, 5, 6 slices in it, and then 2 1/3 then would be 1 extra slice. That's going to give you 7 slices altogether. So 2 1/3 is the same thing as 7/3. Okay. Finally, C, 7 times 7 times 7 times 7 times 7 is equal to 7 to the power of something. Just need to count how many 7s there are, really. We've got 1, 2, 3, 4, 5 of them. So 7 times 7 times 7 times 7 times 7 is going to be 7 to the power of 5. Okay. Question 4, part A, work out 5/6 of 18. So 5/6 of 18, the same thing as 5/6 times 18. Now to work that out, we're going to be dividing first by this number on the bottom here. So how many 6's go into 18? 6 goes into 18 3 times. So divide by 6 gives you 3. And then once you've got that, then you can times the top by times it by the top number, which is times 5, isn't it? So 3 times 5, that is equal to 15. Okay, so divide by the bottom number. First, you're going to get 18 divided by 6 is 3. Take that and times it by 5, you get 15. Okay, £5 take away £1.49. Okay, I'm just going to do this as column subtraction. So 5 is actually 5.00, isn't it, in pounds and pence. If I want to take away £1.49, then 0 take away 9 I can't do, so I'm going to have to borrow one, but I haven't got anything to borrow one, so I'm going to have to borrow one from the 5, aren't I? So if I borrow one from the 5, that makes that one 10, and then if I borrow one from, so that make that 4, and then if I borrow one from the 10, that will make that 9, and then that will be 10 then, won't it? And then 10 take away 9 is 1, 9 take away 4 is 5, and 4 take away 1 is 3. Okay, so it's a bit hard, that one, actually, for borrowing. Another way you can think about it is using the number line. So if you start on £1.49 and you want to get up to 5, let's go through nice jumps then. So if we jump first from £1.49 to £1.50, that would be like 1 pence, wouldn't it? And then if we went from £1.50 up to £2, that would be adding on another 50p. And then from going from £2 to £5, that would be adding on £3, wouldn't it? So altogether we've added on a penny, 50p and £3. So if you take those three amounts and add them up, you'll see you get the same thing, £3.51. Okay, so yeah, some numbers, you know, doing the column method end up being a real pain. But if you're kind of super solid at doing the column method, fine. Otherwise, you can think about subtraction differently, add on to the lower number until you get to the top one, and that might be a nicer way of doing it for you. Next up, we've got some decimal division, 0.15 divided by 5. I'm going to use this using the bus stop method. So 5's into 0.15. 5's into 0 don't go, so I'm just going to write a 0. I'm going to put the dot in the same place. I'm going to say, well, 5 into 1, how many times does that go? It doesn't, so that's another 0. And I'm going to carry the 1 over this time into the next column. And I'm going to see how many times 5 goes into 3. Into 15, it goes in 3 times, doesn't it? Remainder 0. So that's the answer. The answer is 0.03. Question 5a, write 0.3 as a fraction. Now, you probably know, if you've got 123.45, then this one here is the units. This is the tens, and this is the hundreds, isn't it? If you think about place value. And after the decimal point, you've got tenths and hundredths. Okay, so if I've got 0.3, that is 3/10 basically, isn't it? Okay, so as a fraction, 0.3 is just going to be 3/10. Okay, now sometimes you need to cancel these down, but 3 and 10 don't have any common factors, so I'm just going to leave it as 3/10. Now going the other way, writing something as a decimal, 1/4. What I try and do is to make the denominator like a 10 or 100 or another power of 10. Now I can't make it 10, I'm going to make it 100, because 4 times anything isn't going to give me 10. 10 doesn't have 4 as a factor, but 100 does. I can get up to 100 really easy by multiplying top and bottom by 25. 4 times 25 is 100. 1 times 25 is 25. Okay, so so 1/4 is the same thing as 25 over 100. And coming back to my little diagram over here, we could remember that the second digit after the decimal place was 100ths. So this thing is going to be the same thing as 0.25. Okay, so express it as a fraction over 100, and then you can just rewrite it as a decimal over there. You can take the numerator part and rewrite it after the decimal point. Okay, there it is there, look. Question 6, write the following in order of size smallest first. Okay, and we've got 5 decimal numbers. Now when you're comparing decimal, you want to compare the largest place value with the largest place value first. Okay, so these all these numbers have got a units digit in their place value. So I'm just going to highlight all of those yellow. Okay, so first thing off, we're going to that digit is worth the most. So when I compare these, I can see that they're all 5s apart from this one, 0.61. So the 0.61 must be the smallest one because it has the smallest unit. Okay, so I'm going to write that at the front. I've dealt with that one now, so I'm just going to cross it out. Okay, and then I'm going to move on and I'm going to look at my 4 remaining numbers. This time I'm going to look at the tenths column, the next unit along, or next place value along, and see which is the biggest ones there. So the first one is a 9, the second one is a 9, the third one is a 0, and the fourth one is a 9. So 3 of them are the same, and one is a 0, that's the smallest one. So 5.099 is the next biggest. So you're going to write that one down next, 5.099. Okay, so that one's gone. Okay, now next up I'm going to look at the next digit along. Now my first one is kind of run out of digits, there isn't one there. And then that one is a 7 and that one is an 8. Okay, so coming back to the first one, 5.9 blank, that one has to be a 0 then, doesn't it? Okay, there's nothing when we have a 0 there, we don't tend to write it down. So 5.9 is the same thing as 5.90. 0 is less than 7, which is less than 8. So 5.9 is the smallest of those three, 5.9, and then the 5.977 comes next. And then the 5.98 is last. Okay. Question 7, work out the following giving each answer as a fraction. Now the first one, we've got a mixed number plus a fraction. When I'm adding mixed numbers and fractions together, I like to write them all as improper fractions first. So again, we had one like this earlier. You have to multiply those two together and then add on that one, don't you? So 1 times 4 is 4, plus 3 is 7. So 1 3/4 is the same thing as 7/4 plus a half. Okay, so now I've got rid of the mixed number. Next step is to find a common denominator, isn't it? So I've got quarters and halves. So what is a common multiple of 4 and 2? Well, it's going to be 4, isn't it? 4 goes into 4 and 2 goes into 4. So I can leave the first fraction as it is, 7/4, and then the second one I can multiply top and bottom by 2 to get an equivalent fraction. So 1/2 is the same thing as 2/4. Okay, and then finally I can then just add those together. So 7/4 plus 2/4. Now because the two numbers on the bottom are the same, I've got a 4 there and a 4 there, it means I can just go and add these two together, can't I? So the 7 plus the 2, that's going to give me 9. 9/4 is the answer. Okay, now it doesn't say put it back into a mixed number. You could, if you wanted to, rewrite this as 4 goes into 9 twice, so that's 2 1/4. But it doesn't say you have to do that, so it's an extra step. I'm just going to leave mine as 9/4. Okay. Now the next part says 3/8 divided by 2. Okay. Now 2 is the same thing as 2/1, and fraction division is the same thing. Have you heard of keep, change, flip? Keep the first one as it is, 3/8. Change the sign from divide to times, and then flip the second fraction over. So that's the same thing as 3/8 multiplied by a half. Okay, and then with fraction multiplication, just need to multiply top with top, bottom with bottom. Okay, so 3 times 1 is 3, and 8 times 2 is 16. So my answer is 3/16. Doesn't cancel down. 3 and 16 don't have any common factors, so I'm just going to leave it as 3/16. Part C, what is 1/3 times 1/2? Oh, that's an easy one to end with. Multiplying the numbers on the top, 1 times 1 is 1. Multiplying the numbers on the bottom, 3 times 2, that is 6. So that's just 1/6. Question 8, Hannah saves an amount of money each week. Here are the amounts in pounds that she saved in the first 5 weeks of 2019. So she saved £13, £58, £11, £22, and £11. First off, we need to find the median of the 5 amounts. Now, median is a type of average, and median is the middle one, really, isn't it? But it's only the middle one after you've arranged them from smallest to biggest. So first thing I'm going to do is rewrite these numbers. So starting with the smallest, I've got 11 and 11, then a 13, and then a 22, and then 58 is the largest. So then the middle one there is the 13, isn't it? Okay, so £13. The range of the five amounts. A range is the largest minus smallest. In this case, the largest one then, that's going to be 58, and the smallest one is going to be 11. Okay, so we've got 58 minus 11, that is 47. Okay, so £47 is the range. Then finally it says, in the sixth week, she also saved some money. The mean amount that Hannah saved each week over the 6 weeks was £22. How much did she save in the 6th week? Okay. Now, if a mean for 6 weeks is £22, then normally what you do is you, if you want to find the mean of 6 numbers, you would add up all the numbers. So you'd find the total of all the numbers, and then you'd divide it by the number of items or things, or in this case it's weeks, isn't it? So here I've been given the mean. The mean is 22, and I know the number of items, it's 6. What I want to know at the moment is the total. How much was was the total. I can work out the total from that. Now rearranging this then, the total is going to be 6 times 22, isn't it? Okay, so the total then is going to be 6 times 22, which is equal to 5 22s is 110, and a 6 22 would add up to 132. Okay, so we know that all 6 are going to add up to 132. Now what have we got? We've got an 11 and an 11 and a 13 and a 22 and a 58 for the first 5 weeks, and that adds up to 58 and 22, that's 60, 80, and 13 is 93, and 11 is 104, and another 11 is 115. So what I've got so far adds up to 115. So then the sixth week is going to be the difference between those two values that we've just found, isn't it? It's going to be the 132 that was the total for the 6 weeks. 132 subtract the 115, which was the total for the first 5 weeks. So if I take the total for the first 5 weeks away from the total for the first 6 weeks, it's going to leave me with the amount I saved on the 6th week. So what's 132 take away 115? 132 minus 115. 2 take away 5 can't do. Borrow 5 from 12, that is 7. 1 from 2 is 1, and that's 0. It's going to be 17, isn't it? 17. Okay. So 6th week saved £17. Okay, that's my answer. Question 9. The scale drawing shows the position of 2 boats, P and Q. We've given the scale up here. Scale 1 centimetre represents 4 kilometres in real life. Okay. So here's P down here, look, and here's Q over here. Now these lines that have been drawn on, they're the north lines, aren't they? Because this is going to be a question on scales and bearings. So when we've got bearings, it's really handy to draw a kind of north line going straight up, and then we can measure our angles from those lines. But the P's and the Q's are the big dots at the bottom of those lines. Okay, so find the actual distance between the boat P and the boat Q. Now, this is an electronic version of the paper, so my ruler is not going to really match up with reality. But what you would do is you're going to take your ruler and you are going to measure that distance between there and there first. Okay, so you measure this. I'm just going to draw the line in so you know which line I'm talking about. So you're going to measure the length of that line. Now, according to the mark scheme, that distance is 5.5 centimeters. Okay, so on the paper, that is 5.5 centimeters. But remember, 1 centimeter represents 4 kilometers. So if, let's just get rid of the ruler. So if 1 centimeter is equivalent to 4 kilometers, then 5.5 centimeters is what I've got. It's going to be 5.5 times 4, isn't it? So 5 4s are 20. Half times 4 is 2, so that's 22 kilometers. Okay, so the answer to that one then is 22 kilometers. Okay, so the actual boat is actual boat Q is 22 kilometers away from actual boat P, and 5.5 centimeters on the diagram. Okay, measure the bearing of boat Q from boat P. Okay, measure the bearing of boat Q from boat P. So with these questions, you just really need to be careful of these words of and from. Okay, so just make sure you get these the right way around. So you're starting from boat P and you are going to boat Q. So you're heading off in kind of this direction from P. So the angle or bearing we're looking for is this angle here. Okay, that is the bearing of boat Q from the boat P. So we're leaving P, we're going towards Q in that direction. Okay, so all we got to do really is put our protractor over that angle and measure it. Okay, so line up your 0 line with the north line and make sure the center of your protractor is at the point P, and then you can just read round to where the line is, and hopefully you can see from this that it's 65 degrees. So that angle there is 65 degrees. But remember, bearings are given as 3 figure numbers. Okay, so if it's only got 2 or 1 digits, you need to pad it out with some zeros to make sure it is 3 digits. So I'm going to write that down as 065. So the bearing then is 065 degrees. Okay, then finally it says a lighthouse is 18 kilometers from boat P on a bearing of 200 degrees from Q. Okay, so we're going to be at Q this time. We need to head off in a bearing of 200 degrees. Now, if you think about bearings, so if north, if you're at a point, then north is 0, 0, 0. So east, so that's north. East is going to be 0, 9, 0. South is going to be 1, 8, 0. And west is going to be 2, 7, 0. And then we're back to 360, which is 0, 0, 0. So a bearing of 200 is going to be between south and west, isn't it? And if you think about it, it's going to be nearer south than it is to west. So I'm expecting it to be in that direction there. Okay. Now to measure that angle with a compass, with a protractor, sorry, it's going to be easier to measure this angle round here because protractors only go up to 180 and not all the way up to 200. So if this angle round here is 200, then on the other side of it is going to be 360 take away 200, isn't it? That's going to leave me with 160. So I need to measure an angle of 160 back around from the north line. Okay, so I'm going to stick my protractor back over the north line at Q. This time it's kind of heading in the wrong direction because I'm going to go back towards in the southwesterly direction, aren't I? So starting from 0 in the north and counting around to 160, then my bearing then is going to be off in this direction. So let me just get my ruler. So it's going to be along this line here, isn't it? This is a line on a bearing of 200. So 200 from this direction, 200. Okay, now what we've got to do now is work out how far along this line it's going to have to be then. So again, you're just going to get your ruler out and you're going to measure how far it should be from here. Now, it's 18 kilometers. Remember the scale is 4 kilometers is 1 centimeter. So 18 divided by 4. 4 is into 18. 4 into 1 don't go. 4 into 18 go 4 times remainder 2. So that's going to be that, isn't it? Remainder 2. And then 4 is into 20 go 5 times. So it's actually 4.5 centimeters. We need to draw it along this line. Okay, so 4.5 centimeters. So then measuring it down my line, that should be here. Okay, on if you do it on a ruler, you should get it somewhere like there along that line. Okay, so just going to measure this so that it's a distance of 4.5 centimeters along this line. Okay, and then mark your point. Okay, and then that is the point. Oh, what do I have to do? On the scale drawing, mark a possible position of the lighthouse with a cross. Okay, so I need to show that as a cross. So lighthouse. Okay, there's my lighthouse down there. Okay. Question 10. A man running at a constant speed of 5 meters per second takes 66 seconds to complete a particular distance. A horse completes the same distance running at a constant speed of 15 meters per second. Find the difference in seconds in the time taken by the man and by the horse to run this distance. Okay. So we've got two things. We've got man and we've got horse. Okay, so let's make a man and horse section. Okay, now this problem is involving distance, speed, and time. So let's just make a note of the DST triangle, distance, speed, time, because this helps us work out what formulas we need to use, etc., etc. Okay, so we need distance, speed, time for each, don't we? Or maybe we do. What do we know? Do we know any of those things for the horse and for the man? So let's go through the man stuff first. Man running at a constant speed of 5 meters per second. So speed 5 meters per second. Okay, so we've done speed. What else have we got? We've got takes 66 seconds to complete. So that is the time then, isn't it? So then time is 66 seconds. We don't have distance. It's a particular distance, haven't we? We've got a particular distance. So we don't have a exact distance. We don't know D. Right, for the horse, completes the same distance. So we don't know what the distance is, but it's the same. So I think I'm just going to use an X there and there, aren't I, for now? That's going to be X, distance X, because it's the same for both horses and man. Okay, and now that is running at a constant speed of 15 meters per second. So speed is 15 meters per second. So that one there is 15 meters per second. Find the difference in time. So obviously we don't know the time for the horse. Okay, so we've got to work that out. Okay, so here's the plan. So if you look at man, we know 2 of the 3 things. So we're going to use the distance, speed, time triangle to work out the missing one. Then we know what the distance is for the horse, and then we'll have the speed, and we can use those 2 things on that one to work out time. That is the plan. Okay, so let's go ahead. First off, let's work out the distance that the man ran. So distance, you can see it's the top of the triangle, so I'm just going to cover that up. So that tells me that distance is equal to speed times time. Okay, because speed and time are on the same line, that means that we're going to multiply them together. So the speed is 5 and the time is 66. When I'm multiplying by 5, then I find the easiest thing is to halve your number and then times it by 10. That's the same thing as multiplying by 5, because half of 10 is 5. So 66 divided by 2 is 33, and then put a 0 on the end is 330. So it's just a bit of a tip for you. So that's going to be in, we had meters per second and we multiplied it by seconds, so that's going to give me meters, 330 meters. Okay, so that means that this one over here must also be 330, because this one was 330. We found it now. Okay, so the distance is the same. So now for the horse, again, if I've got like a DST triangle, this time I've got distance and speed. What I want to do is find time, this one here. So time then is equal to distance. Can you see that distance is above speed here on the table? So that's distance divided by speed. Okay, so then subbing in the distance that we now know is 330, because it's the same as the other one, divided by speed, which is 15. What's 330 divided by 15? So let's just do 15 into 330. 15 into 3 doesn't go, carry the 3 over. 15 into 33, well that goes twice, doesn't it? Remainder 3. And then 15 into 30 also goes twice, remainder nothing. So that is then 22. 22 what? We had meters and we divided it by meters per second, so that is going to be seconds. Okay, so it's going to be 22 seconds. Question 11, part A. Alice buys a picture for £180 and later sells it for £216. Find the percentage profit she made. Okay, so what is the profit first? Profit is going to be the sale price, 216, minus the price it cost her. 216 take away 180. 216 minus 180. 21 take away 18, that's 3, isn't it? So it's 36. So she's made £36 profit. Okay, now what we want to know is what is that as a percentage of the total amount she had to start with. So she paid £180 for it and she made £36 profit. So her percentage profit is going to be 36/180th rewritten as a percentage, isn't it? That's the fraction profit she made, so we want to make that into a percentage. So how can I turn 180 into something like 100? I want to make it 100. Okay, so eventually I want to make this as a fraction over 100, so I can then read off the number on the top as the percentage. So if you have a look at 180, is there kind of a stepping stone in the middle I can go to scale it up to 100? Well, if I divide both sides by 9, so if I divide by 9, divide by 9, that's going to give me a fraction over 20. And then if I take that number and I times it by 5 and I times it by 5, that's going to give me a fraction over 100, and then I've got my percentage that I need. Okay, so what is 36 divided by 9? 9s into 36 go 4 times. So 36 180ths is the same thing as 4 20ths. And then multiplying top and bottom by 5. 4 times 5 is 20. So 4 20ths is the same thing as 20 100ths. And that is the same thing as 20%, isn't it? So what is the percentage profit she made? She made 20% profit. Okay. Rashid wants to increase £345 by 17% in one step by using a decimal multiplier. Write the decimal multiplier to complete Rashid's calculation. So she wants to increase it, a percentage increase. With a percentage increase, you start with 100% and you add on your percentage increase, which is 17%. So that is 117%. And 117% is a decimal. Divided by 100, you're going to get 1.17. And that is the multiplier we're going to have to use there in order to get there in one step. So 1.17. Question 12. In an exam, Adam scored the following marks. In paper 1, they got 17 out of 20. And in paper 2, they got 19 out of 25. Part A says, show that he scored a higher percentage in paper 1 than in paper 2. Okay, so what we need to do is to take both of these as fractions. So paper 1 was 17 out of 20, and paper 2 was 19 out of 25. And we need to rewrite these as percentages. So same as last question, we're going to rewrite this as a fraction over 100, and then we can read off the percentage after that, can't we? Okay, so how many times does 20 go into 100? It goes in 5 times. So if I multiply that by 5, I get 100, but I need to multiply that by 5 as well. What's 17 times 5? Well, 17 divided by 2 is, what's that? 8.5 times 100 is 85, isn't it? So that's going to be 85 over 100, which makes it 85%. The other one, 19 over 25. 25 goes into 100 4 times. So multiplying top and bottom by 4. What's 19 times 4? Double it and double it again. 9 times it by 4, isn't it? So double 19 is 38, and double 38 is 68, 76, isn't it? So that's 76 over 100, which is the same thing as 76%. So show that he scored higher percentage in paper 1 than paper 2. We can say that 85% is greater than 76%. Okay, so we've shown it. Okay, part B says the 2 marks are added together. Work out Adam's overall percentage for the 2 papers. So if you got 17 out of 20 for the first one, and he got 19 out of 25 for the second one, then altogether then he got 17, 27, 30. He got 36 out of 45 as a total, didn't he? Okay. I'm not actually adding these fractions together. That's not going to give you 36 out of 45. I'm just combining his total scores out of the total marks for the both papers. So he got a combined score of 36 marks out of a combined score of 45. I'm not actually adding those fractions together. Okay, so then what I need to do is express that number as a percentage. So what is 36 over 45 as a percentage? Okay, now again, I need to get this as a fraction over 100. So again, I need to find a way of expressing this as a fraction over 100. So is there like a nice intermediate jump I can do in order to go from one to the other? Well, I can see 36 and 45 are both divisible by 9. So 9's into 45 go 5 times. If I divide this one by 9 and this one by 9, so 36 divided by 9, that is the same thing as 4, and 45 divided by 9, that is 5. And then what do I have to do with 5 to get 100? I need to multiply it by 20 basically, don't I? 5 times 20 is 100, so doing the same with that one. 4 times 20, that is 80 over 100, and 80 over 100 as a percentage is 80%. Okay, so what was his overall percentage for the 2 papers? It was 80%. Question 13a part 1, sketch the graph of y is equal to 2. Okay, now any line which has the equation y is equal to just a single number, that is going to be a horizontal line. Okay, so it's going to be a horizontal line like this. Okay, and then the value it passes through the axis, and the value it passes through the axis here then is going to be that value. So that's going to be 2 there. Okay, so it's going to pass through the y-axis at 2. So that's my sketch. Doesn't need anything more than that, just the point of intercept and the basic shape of the graph. Okay, the second graph says sketch the graph of y equals x plus 1. Okay, so this is the equation of a straight line. Equations of a straight line are always written in the form y equals mx plus c. So here, if I've got y equals x plus 1, then the gradient of this line, you might think it's missing here, but it's actually one lot of x if you think about it. So the gradient is 1 and the y-intercept is 1. Okay, so that means this line, a gradient of 1 is just a 45-degree line. Okay, for every 1 unit you go across, you go 1 up. Okay, and a y-intercept of 1 means that you're going to pass through the y-axis at the point 1. Okay, so let's move out of the way because my point is catching on the ruler. So that is the point 1 there, and my line so then is going to be like a 45-degree line going through that point. Okay, so it's just going to look like that. I suppose I should do the other intercept down here. It's a good practice to just mark on all the intercepts. Now that one there, if I'm at 0, 1 and I go 1 unit to the left and 1 unit down, I'm going to end up at -1, 0. So that point there is going to be -1. Okay, where it passes through the x-axis. So it's a good idea just to label all of your intercepts like that. Part 3 says, Seri says, oh, I don't know how to say that, Seri? Kerry, or I don't know, whatever it is. Kerry says that the graph of y equals 2 and the graph of y equals x plus 1 cross at the point 2, 3. Okay, so that's basically the 2 graphs we drew, isn't it? So if I superimpose the first one onto the second one, it would look something like this, isn't it? It would look something like this. So this was the line, let's make sure I label them because I've got 2 on the same graph. This is the line y equals x plus 1, and this is the line y is equal to 2. So what Seri or Kerry is saying is that point there is the point 2, 3. Is it? Now I don't think she can be right because a gradient of 1 means for every unit you go along 1, you go up 1. So in order to get to that line, really we only need to go 1 unit along and 1 unit up, and we're already at a height of 2 above the axis. So I reckon that point there is not 2, 3. It's actually 2, well, it's actually 1, 2, isn't it? It's 1, 2, not 2, 3. Should be the point 1, 2. So if I'm at 0, 1 and I go 1 to the right, I'll be at 1, 1, and if I go 1 up, I'll be at 1, 2. Okay, so that should be the point 1, 2 and not the point 2, 3. Okay, so I'm going to answer this question mathematically. I'm going to say that she should have said 1, 2 is the point. Okay, so she should have said it was at 1, 2, not at 2, 3. Okay, she's gone one more further along and one more further up. The other thing you could say, like 3 is not on the line y is equal to 2 because the y coordinate is too much. Okay, so the other thing is that, the y coordinate had to be 2 would be a good answer. Yeah, lots of different ways of answering that, but I just found the point and I saw it was 1, 2, so that's my solution. Question B, Oliver has sketched the graph y equals x squared below, and we need to make 2 comments about the accuracy of his sketch. Well, the first thing I'm noticing here is that it is drawn in straight lines, isn't it? Straight line, straight line, straight line. Okay, so rather than drawing a nice smooth curve through his points, he's drawn them with a ruler, which is not so nice. Okay, so my first comment is going to be Oliver used a ruler to join points rather than a smooth curve. Okay, so he should have used a smooth curve and he's used a ruler. Okay, the other thing is the graph of y is equal to x squared should go through the origin, shouldn't it? Because if x is 0, then 0 squared is 0. So it should go through the point 0, 0, and it doesn't. So I'm going to say graph should pass through 0, 0. Okay, and it doesn't. It goes through 0, 1. Okay, so that's my other criticism. You could also say that the intercept is not shown on the graph, so they haven't labeled it. That might be another criticism that you could make. Okay, it doesn't actually say criticism, so it just says comment. So I suppose you could say that he's done a symmetrical graph, which is right. Okay, so that's a positive thing about it. But yeah, they're the 2 that I've picked. Question 14a, write each of the following ratios in their simplest form, 8 to 10. Now you can cancel ratios down the same way as you can with fractions. What you got to do is find a common factor. Okay, so a common factor for 8 and 10, both 2 goes into both of them, don't I? So I can divide both numbers by 2, they're both even numbers. So if I divide both sides by 2, I'm going to get 4 to 5. Okay, now 4 is still an even number. I could divide it by 2 again, but 5 is prime, so I'm not going to be able to cancel that down any more than it already is. So that's my answer, 4 to 5. Okay, now if I wanted to do something similar with this next one, 300 milliliters to 2.1 liters, just take care here because I've got different units here, haven't I? I've got milliliters and liters. Now I know there are 1,000 milliliters in 1 liter. Okay, so 2.1 liters is going to be 2.1 times 1,000. It's going to be 2,100 liters. So this ratio is not 300 to 2.1. It's actually 300 to 2,100, isn't it? That's the ratio there that I should be working with. Okay, now I'm going to immediately make it easy for myself by dividing both sides by 100. So let's make it 3 to 21. And then I can easily see, well, they're both divisible by 3. So dividing both sides by 3. 3 divided by 3 is 1. 21 divided by 3, that is 7. So it's the ratio of 1 to 7. Question 15. Angie is planning a presentation evening. She writes down her costs and income. So her costs are 10 staff, each working 6 hours at £8 an hour. Food, 60 meals at £8.95 each. Prizes, 12 prizes at £19.99 each. Income, 60 guests paying £5. Sponsorship, £1,000. Okay, so Angie thinks she will make a small profit. Use estimation to decide if Angie is correct. Show all your working. Okay, so the key question here, or the key word here, is estimation. Use estimation. So when we're estimating, we're not using all the information from the numbers. We're just kind of finding a rough and ready version of the number and using that in our calculations. Okay, so the first one, 10 staff each working 6 hours at £8 per hour. So I'm going to have to work out 10 times 6 times 8. Now these are all numbers to one significant figure already. So for these ones, I'm not gonna round them off at all. I'm just gonna use those numbers. I'm gonna do the 6 times 8 first. 6 8s are 48, and then I can times that by 10. That's 480. Okay. Food, 60 meals at £8.95. Now this time I am going to round these off. So 60 times, rather than using £8.95, I'm just going to round it off to the nearest pound. I'm going to do 60 times 9 then. What's 60 times 9? Well, 6 9s are 54. So 60 times 9 is 54 with a 0 on the end. It's 540. And then I've got 12 prizes at $19.99. So 12, I'm going to round off to 10. That's one significant figure. And £19.99, I'm going to round off to one significant figure as well. I'm going to round it off to 20. So 10 times 20, that is 200. So all my costs altogether are going to be 480, 540, and 200. So costs, 480, 540, 200. So what does that equal to? 0, 2, carry 1, 4, 5, 10, 12. So that comes out to be 1,220. Okay. Then we're going to do the same thing with our income. 60 guests paying £5. Again, these are all one significant figure numbers anyway. So 6 times 5, that is 30. Add a 0, that is 300. And sponsorship of 100, well, 1,000, that's just 1,000, isn't it? So then income is going to be 1,000 plus 300. That comes to be 1,300. Okay, so using estimation, I've got an income of 1,300 and a cost of 1,220. So profit is then going to be one take away the other, isn't it? 1,300 minus 1,220. That's a difference of 80. Okay, so I think she's going to be making a profit of around £80. Now, obviously, it's not exact because this one in particular I rounded off and also rounded this one off. But I could be confident there that she is going to make a little bit of profit, I think. Martina has answered some questions on algebra. In each question, she has made an error. Describe her error and give the correct answer to each problem. Question 1. Simplify 2a times a times a, and Martina's answer is 4a. Okay, well, I think what Martina's done there is she's added the things together rather than multiply, hasn't she? So I'm going to write down that she has added the terms and not multiplied. Okay, so what should she have done? Well, she should have multiplied them together. 2a times a times a is going to be 2a cubed, isn't it? Okay. Question B says simplify x to the power of 10 divided by x to the power of 2. Martina, she's not very good at algebra, is she? She's written x to the power of 5. What's Martina's error? Well, she's basically divided these powers, isn't she? 10 divided by 2 is 5. Where laws of indices says if you have two numbers with the same base, you subtract the indices. So her error is she has divided the indices when she should have subtracted them. Okay, so if she had subtracted them, you would have got x to the power of 8 and not x to the power of 5. Question C. We've got the formula S equals ut plus half at squares, which is one of the laws of motion. Find S when u is 0, t is 5, a is 6. Now Martina's solution is, well, she's subbed correctly. 0 times 5 plus half times 6 times 5. 0 times 5 is 0, that bit's good, but it's this bit here that's not correct, is it? Okay, what she's done is she has multiplied these three things together. Half times 6 is 3, and then multiplied by 5 is 15, and then she squared the 15 afterwards. Whereas BIDMAS would say that you're meant to do the squaring first. So she's meant to have squared 5 squared first, and then multiplied by 6.5, etc. Okay, so what's Martina's error? She has not followed BIDMAS and squared first. So what should it be? If you did square it first, 5 squared is 25, and then half times 6 is 3, 3 25s is 75, plus 0 is just 75, isn't it? So the answer should have been 75. Okay. Question 17. The diagram shows the scale drawing of a garden, ABCD. The scale is 1 centimeter represents 5 meters. And we can see that we've got like a kind of odd-shaped quadrilateral garden here. And there's a bit more information at the bottom. It says a tree is to be planted in the garden so that it is at least 10 meters from AB and closer to CD than CB and at least 15 meters from D. Using a ruler and compasses only, construct and shade the region in which the tree can be planted. Okay, so we're going to need some kit here. We're going to need to have our ruler, a short pencil for working with the compass, a long pencil, and our compass. Now I always keep a little pencil in my pencil case for compass work. Make sure it's nice and sharp. When you put it into the compass, make sure the tip of the pencil and the tip of the compass are in the same place before you tighten it up. Okay. Now the reason why you need a short pencil is that you need to be able to twirl a compass all the way around 360 degrees. And if you've got a long pencil, it's going to clunk into your hands all the time, and it's going to make drawing arcs really tricky. Right. Okay, so we've got to do some construction here. Okay, some loci. So at least 10 meters from AB. So in other words, we're going to have to draw or construct a parallel line parallel to the line AB, which is 10 meters away from it. Now the scale we've got is 1 centimeter represents 5 meters. So a 10 meter scale is going to be 2 centimeters on my drawing, isn't it? Okay. Now to construct a parallel line, what I'm going to do is I'm going to draw a series of little arcs that are a radius of 2 centimeters based on that line AB. So I'm going to start at A and at B and draw my 2 little arcs. And I think I'm going to do a couple in between. Okay, now once I've done those, I'm going to get my ruler and I'm going to push it up against those arcs. So it's just touching each of those arcs. Now that line then should be exactly 2 centimeters away from AB. So that's going to be my parallel line. So I'm going to draw it across the top of those arcs like that. Okay. Now don't rub out any of your construction marks in loci because they count. Right, next we're going to do closer to CD than to CB. So what we're going to need to do now is an angle bisector of the angle DCB. Now to start that off, I'm going to take my compass and I'm going to draw an arc that cuts both arms of the angle. It doesn't really matter how long the arc or the radius of the arc is. But the important thing is to not change it when you're doing these marks in the middle. They have to be equidistant from those 2 marks that you made. Okay? So putting your compass in each of the marks that you made and drawing another arc in the center. That should form a cross, and then we're going to join C up through that cross, and that is going to be my angle bisector. It's going to cut that angle exactly in half. Okay? Now we wanted the points closer to CD, so we want the ones kind of above that line then on that side, don't we? Right, now finally we need to do at least 15 meters from D. at least 15 meters from D. So again, it's because I've got 1 centimeter represents 5 meters. That's going to be 3 centimeters then. 15 meters is going to be 3 centimeters on my scale. So I'm going to set my compass to exactly 3 centimeters. And I'm going to draw part of a circle based at D. Okay, now obviously I don't need to draw the full circle because the tree has to be in the garden. So just a bit of the circle that lies in the garden. Okay, so now they're all my constructions that I need to do. Now I need to be further away than 10 centimeters from 10 meters from AB. I need to be closer to CD, and I need to be further away than 15 meters from D. Okay, so it's that bit in the middle there then, isn't it, where all the arrows are pointing to. That's the region I want. So I'm just going to shade this bit. So my tree can go anywhere inside the shape, including this bit up here. That little arc at the top was just a construction mark. It didn't have to be outside that. So that's it. That's the bit that I want. Okay? Good job. Solve by factorising. X squared plus 9x plus 20 is equal to 0. Okay, well, if a quadratic factorizes, it's going to factorize into 2 brackets like that, isn't it? So I've got a x squared term at the front, so I must have an x and an x here. Now at the back of my equation I've got a plus 20. Now the 20 is going to come from multiplying this one with this one, isn't it? So I know that those two numbers must be a factor pair of 20. So what are the factor pairs of 20? I've got 1 and 20, 2 and 10, 3, nope, 4 and 5. So I've got 3 possible pairings, 1 and 20, 2 and 10, and 4 and 5. Now I'm looking for the combination that's going to give me that plus 9 in the middle, and the only one that's going to do that is this one here, the 4 and 5, because that adds up to 9. So it must be x plus 4, x plus 5 is equal to 0. Okay, so I've factorized, but I haven't solved. If I've got 2 things multiplied together to give me 0, then one of those things must have been 0, or the other thing must have been 0. Okay, in which case x must have been minus 4, or x must have been minus 5. Okay, so they're my 2 solutions. Minus 4 and minus 5. On a plane, 2/5 of the passengers were British. 30% of the British passengers were men. There were 36 British men on the plane. Find the total number of passengers on the plane. Now, I think the easiest way to set this up is look at it as a 2-way table. So if I do a grid like this, and I say British, not British, and I do male, female, then I should be able to work everything out using this grid, I'm hoping. Okay, so then I can put totals down the side, totals down the side like this. I think this might help me work out what the answers are. Okay, so I don't know how many there are. Oh no, I do. I know that there were 36 British men on the plane, so I can put 36 here straight away. Okay, so I've used that bit of info. 30% of the British passengers were men. Okay, so 36 represents 30%. Okay, so 10% would be a third of that, would be 12. So 100% would be 12 times 10, it would be 120. Okay, so that means there must have been 120 British people on the plane altogether. So if I take 36 away now from 120, it should tell me the number of British females on the plane, which is going to be then 84 then, isn't it? Okay, right, so we've used that bit of information, we've used that bits of information. What's left? We've got 2/5 of the passengers were British, so 2/5 were British. So 120 is 2/5. So that means not British is going to be 3/5 then, isn't it? So if 2/5 is 120, then 1/5 is going to be 60, and 3/5 is going to be 180 then, isn't it? Okay, so then the total is going to be, well, it's going to be 300. Okay, now I haven't quite finished my my two-way table, but we've already answered the question, haven't we? It just asked me to find the total number of passengers on the plane, and I've kind of done that already. It must be 300. Okay, so I didn't need all these other boxes, but hey, at least I got to a solution, so I'm happy. So 300 passengers on the plane. A bag contains 100 pencils that are either red or green. Describe a method you could use to estimate the number of red pencils in the bag without looking into the bag or having more than one pencil out of the bag at any one time. So I think the best way of estimating this would be to do some trials where we take a pencil out of the bag and we note its color either red or green, and we repeat this process over and over and over again until we get an idea of how many are red and how many green overall. So perhaps if we ran if we did 100 trials, then we should have enough data to kind of come up with a good estimate of how many red and how many green ones were in the bag. Okay, so that's what I'm gonna say. I'm gonna say we will conduct the following experiment 100 times. Select one pencil at random from the bag. Record the color and then replace the pencil back in the bag. Once complete, we can use the number of each color drawn as an estimate for the number of each pencil in the bag. Okay, we will conduct the following experiment 100 times. Select one pencil at random from the bag, record the color, and then replace the pencil back in the bag. Once complete, we can use the number of each color drawn as an estimate for the number of each pencil in the bag. The diagram shows a kite ABCD. AFE and CEF are equilateral triangles. And the first question says, write down the mathematical name of quadrilateral AFCE. Okay, now AFCE is AFCE. It's this quadrilateral here. Okay, now before we can answer what that question is though, we don't really have all the information yet from the question on the diagram. Okay, we're told in the question that diagram shows that ABCD is a kite, and we're also told that AFE and CEF are equilateral triangles. At the moment that information isn't on the diagram, so let's put that in first. Okay, so ABCD is a kite. That means that that length must be the same as that one, and it must mean that, well, I'm not sure about this one. I'm thinking this length here, but it's divided into two. It might be easier just to break that up and look at the other lengths first. I'll come back to the kite. Let's have a look at AFE. AFE, AFE. So we know that this side is equal to this one, which is equal to this one, because they are all equilateral triangles. Doesn't actually look like it, but it's not to scale, so don't be fooled. Okay, so we know those for all those sides are the same, and also in CEF, so this side must be equal to this side, must be equal to this side. Okay, so now we can see that all the sides of the quadrilateral AFCE that we were looking at are the same, so that makes the shape a rhombus, doesn't it? It's going to be a rhombus. Okay. But remember, this was a kite, so we can also say that this side here, this side here must be the same as that one, so that CB is going to be the same as CD. Okay. So right, I think we've marked everything from the question onto the diagram. Let's see if we can answer part B now. The ratio of angle DAE to angle AEAF is 1 to 4. Work out angle X. Angle DAE. DAE. So this one to EAF. That one. Okay. They are in the ratio of 1 to 4. But we know what this one is already, because it's an equilateral triangle. So DAE to EAF are in the ratio of 1 to 4, but we know that EAF is 60, which is 15 times bigger than 4, isn't it? Okay, so if I multiply the other one by 15 as well, we should be able to see that DAE is going to be 15 degrees then. Okay, is that what we need to find? Nope. So that's 15 degrees. We're still busy. Okay, now we know that that one must be 60 because it's in an equilateral triangle, and we know that that one must be 60 because it's in an equilateral triangle. So I'm guessing then that this one must also be 60 because it lies on a straight line then with the other two, and it has to add up to 180 degrees. Okay, so if that one is 60 and that one is 15, then what's left is going to be X then, isn't it? So X plus 60 plus 15 is 180. So 60 and 15 together is 75. Take that away from 180. X is going to be 105 degrees. Question 22. In a group of 100 students, 59 study history, 62 study geography, 20 do not study either subject. And the first question is to complete the Venn diagram. Okay. Now, looking at that information, 20 do not study either subject. That's already on the diagram. It's down here. Okay. What we need to do is we need to work out what goes in those three boxes. But unfortunately, it's not as straightforward as it first might seem. So this 59 who study history, that's got to go somewhere in this circle. Now, some of those historians are also going to be studying geography. So some of them are going to be in the middle, and some of them are just going to do history only, and they're going to be in the left-hand side of that circle. And it's the same with the geography people. I've got 62 people who study geography. So some of them are going to study history as well, and appear in the middle, and some of them are just going to be in the geography side. Now, the way that information is presented, we don't know that the size of that overlap in the middle, how many people actually do both in the middle. So to start off with, I'm going to say, well, let's say that the number in the middle is X, okay? So if there are X people who study both history and geography, then how many people just study history? That must be my 59 that study history altogether minus the X who study both. Okay, and then on the other side, how many people study geography only? there's the 62 who study geography minus the x who study geography and history, like that. Okay, so I know this looks a bit complicated for now, but what we're going to do is we're going to work out what the x is, and then once we know that, we can complete the Venn diagram. Okay, so what we do know, we know that everything adds up to 100 students. Okay, so the 4 different zones of my Venn diagram need to add up to 100. So what we're going to do is we're going to form an algebraic linear equation in x, which we can go on and solve and then complete our diagram. Okay, so the 4 different zones, I've got the history only zone, which is 59 minus x. Okay, that's the history only. The bit in the middle, which is x. The geography only, which is 62 minus x. The 20 who did neither. All of those added together is every student, so that must be equal to 100. Okay, right, so we need to collect like terms together here. So I've got 59, 62 and 20, and I've got x minus x and minus x. Okay, so I'm going to collect those together. So let's do the numbers first. 59, 62 and 20. 62 and 20 is 82 plus 59, that's 82, 91, 141. So that the numbers add up to 141. I've got positive x minus x minus x, so that adds up to minus x altogether. So 141 minus x, that is equal to 100. Okay, so 141 take away my x value is 100, so that means x is 41 then, isn't it, basically, because the different if I take 41 away from 141, I'm going to get 100. So x is 41. So that's my number that goes in the middle. So if x is 41, I can now write that number in there, because I now know that x is 41. But I also know the other ones as well, because if x is 41, then 59 take away 41. 59 take away 41, that is 18, isn't it? Okay, so there's going to be 18 that go there, and 62 take away 41, that is 21. Okay, now at this stage you might want to check that your 4 zones do add up to 100. You got it correct. So I'm just going to double check. 18 plus 41, that's 59, plus 21, 60, 80 plus 20, that does add up to 100. Okay, so I'm pretty confident I've got it right. Okay, now part B says one of the 100 students is selected at random. Find the probability that the student studies exactly one of the 2 subjects. So the probability that is exactly one subject means that they are either studying history only, so one of those 18, or they are studying geography only, which is 21. Okay, so the probability that is exactly one is the successful outcomes, which is my 18 historians only plus my 21 geography only students, divided by the total number of outcomes, which is 100 in this case, because I've got 100 students altogether. So 18 plus 21, that comes to 39 over 100 then, doesn't it? Okay, so I've got 39 chances in 100 of selecting a student that studies exactly one subject. So I've got a 39 chance in 100 of picking a student who studies exactly one of the 2 subjects. Question 23. A straight line with gradient 4 passes through the point 1, 5. Find the equation of the line in the form y equals mx plus c. Okay. Right, well, straight off, I know what m is, isn't it? Because my m stands for the gradient, and it tells me that the gradient is 4. Okay, so I can say straight away that m is 4. Okay, so then the equation is going to be of the form y equals 4x plus c, where c is the y-intercept that I don't know yet. Okay, so it's going to be of the form y equals 4x plus c, because I know the gradient is 4. Okay, so all I really need to do now is find out what c is. Now I can use this fact here that it passes through the point 1, 5 to identify c. So I can say line passes through 1, 5. Okay, so that means I can sub those values in for x and y. If that point lies on the line, it should be true when I put those numbers in the equation. So if y is, so this is the y value, isn't it? So that's going to go here, and this is the x value, so that's going to go here. So if I sub those two numbers in there and there, it should be true. And so 5 equals 4 lots of 1 plus c, and that's got to be true. So 5 equals 4 plus c, just multiplying out that bracket. Okay, take 4 away from both sides, minus 4, minus 4. That tells me that 5 take away 4 is 1, c is equal to 1 then, isn't it? So therefore, the equation of the line is going to be y equals 4x plus 1. Okay, got my line now. That's it. That's all you have to do. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.